Halo guys, namaste, Brev, Ndiepi, Sanbonani. Anyway, we have Lenovo. Right, so this is from Robin. It's a nice machine. Right, so okay. Right. Alright. Anyway, this was it's not turning on according to the client. Let me see what exactly going on here. So what you do, you connect a DC bench. I'll be using a DC bench power supply. Let me limit some amps. Let me drop them down a little bit. And then you connect the positive to positive, hoping it will charge. And then ground to ground. All right. Press the power button. The machine is not turning on. Let's open it inside. Alright, the screws are not connected. There is no screws on this machine. I'm not sure whether I will win on this because I can see someone worked on it before. Okay, the first thing, you disconnect the battery. It's very important to disconnect what? To disconnect the battery. You have to disconnect the battery always. I remove this hinge. All right, guys. Let's see. This is an Asus liquid damaged. Okay, so now what we need to do, we need to check for a short on the 19 volt. Turn on the meter. You put one probe to ground, and then you check. No short near the CPU. No eyeball. Wait. I made a mistake. Let's check. We have a short to ground. There's a short on the 19 volts. Okay. Remember how you chase the MOSFET DC in? You will have the first MOSFET. After the first MOSFET, you will have the second MOSFET. After the second MOSFET, you will have the current sensor, guys. So in my case, let me show you what exactly. All right, here we are. We have a DC in jack. Right here, this is a DC in jack. So when you follow the DC in jack, you will see the first and the second MOSFET. Okay, there we go. This is the coils. Those three little coils there, inductors that allows the 19 volt to flow. You have the first MOSFET. After the first MOSFET, you have the second MOSFET. After the second MOSFET, you have the current sense. And we have a short, as I was showing you. We have a short on the current sense. Here there's a short. The short, guys, come on. The short is not coming from the current sensor. Don't get me wrong. The short is not coming from the current sensor. Obvious. The current sensor, it's like a wire. It only checks how the power that passes through to tell how many watts, how many amps the machine is withdrawing. Don't get me wrong. Don't go and say, Bongi said that this and that. No, I didn't say that. Come on, guys. I didn't say that. Please don't get me wrong. Because I've seen some of you, they will lie and say I said the short is coming from the current sensor. The current sensor is more like a wire. It only allows power to flow through it so that the machine can tell how much power the machine is withdrawing. That's all. That's what the current sensor does. As you can see, those two little dots there, the in and out. They can see when power went in and the power went out. That's all. It senses this thing, the power that passes through this thing. Alright guys, so what you do, you inject the 19 volts. You need to put a wire here because we'll have to inject the 19 volts. Let me just otherwise let me just inject it here. But I feel like where I was injecting, it's too risky because it's close to ground. So I feel like I better inject it right here on this big thing. That's a 19 volt. I did check and confirmed. Need to be sure that you are injecting the 19 volts, because imagine if you are injecting 19 volts on the wrong power rail and you'll be sending like 19 volts on a 1 volt power rail and you will burn the entire components there. So please try to be very careful there. All right. Okay. All right. So now we inject the 19 volts. Otherwise, before we even inject, sometimes it's even possible to detect a short. I'm gonna try by all means to detect a short using my own eyes. Alright, this is not good. Let's just pretend as if I didn't have a DC bench power supply. Let me see what I can do if I didn't have the DC bench power supply. For people who doesn't have the DC bench power supply, it's still possible to repair any machine without wasting time. So, judging by the thing, I want to show you something. Alright, that cap there doesn't look good. So I'm gonna start with that cap, remove it, and then check it for short. Alright, let's check this guy. Alright, still there is no short. I mean, okay, this cap was not shorted, but we'll have to replace this because it didn't look good anyway. So we need to make this board smooth and new. This doesn't look good. Let's reflow this. What about this? The startup chip. The startup chip doesn't look good as well. So now we are reflowing the entire thing. All right, what about this startup chip? I don't want to play around with the startup chip, so you should be very careful with the startup chip. Please be very careful with the startup chip. Do we still have a shot after removing that one cap there? We still have a shot. This tiny resistor here doesn't look good. Look rusted. All right. Okay, these caps, we have these two MOSFETs here there. They don't look good. Now let's check for shots. All right, guys, the shot is gone. The shot is gone. The shot is gone. The shot is gone. Let me remove this wire. Again, we removed some MOSFETs, so we need to check which one of the components is causing this. We need to know whether it's the MOSFET or whether it's the, okay, it's not the MOSFET. Put it on diode mode. 485, that's perfect. You reverse the probes. It's 00, meaning it's fine. Check the other one. No reading, and then you reverse the probes. 400, it's fine. Even though they were so funny or whatever, but they are fine. What about this one? Wait, let's see. The caps lock, I mean the cap, the ceramic capacitor, the cap is the one shorted. Let me show you the condition. I'm saying the caps lock, imagine I'm saying the caps lock. Let's check the condition of this cap. Imagine guys, I'm saying the caps lock. How fun is that? There we go. This is the cap that was shorted. Oh yeah, you can see as well. Doesn't look good at all. Anyway, yeah, this is it. Oh wait, let's put back those components. The one I removed. Let's put them back. Those were MOSFETs, if I remember very well. I removed 2 MOSFETs. There we go. All right, guys. I'm not sure if the battery does have power. You can try with the battery. Let's see. Okay, no light, not charging, it's not turning on. This is bad. We have a big ground pad here. Let me put some solder because I want to connect the ground. There we go. My ground has been connected. All right, guys, it's not charging. Hold on. No light is not turning on. I think the issue is the port. I don't trust this port. All right, there we go. I saw a light, a tiny flash of a light. Okay, there we go. It's charging. It's turning on. Do we have a display? All right, so now it's busy. What do you call this? Resetting. It's taking 1.6 Asus. There we go. Anyway, this is it, guys. I love you so much. Bye bye, and take care. This is working 100%. Bye.